Okay, so this video is about driveline angle. I have a 2000 Toyota Tacoma pickup truck. So to prep the car, you need to make sure that the vehicle is in neutral in the parking brake release, because we need to turn the drive shaft to get these U-joints in position. So you can't have it in park in the parking brake set. So I want to have the U-joint right here. I want to have this U-joint which goes into the yoke of the transmission facing down. I don't care about the drive shaft U-joint. Okay, so I'm going to turn this real quick and you'll see I don't care about this U-joint. Okay, because I could get that measurement off of the drive shaft. To measure the drive shaft angle, you want the U-joint, these joints, which is part of the trunnion, you want that to be 90 degrees. So if it's like 90 degrees straight up and down through the center line of the transmission. So this is right where I want, and if you go back here to the back, this is now the U-joint attached to the differential. So this U-joint will match the angle of the differential. This U-joint will match the angle of the transmission. And then the drive shaft itself will be the angle of the actual drivetrain or drive line. The big thing about your angles is this angle might be 3 degrees positive. We need this angle to be 3 degrees negative to cancel that out. So as close to zero as possible. When you start getting a degree or more of difference in the two angles, then you start getting vibrations in your drivetrain or driveline. Okay? So you must have the two angles cancel out each other to eliminate any vibration problems. You need to download TreeMech toolbox, and it gives you a driveline angle finder as part of the tool. These other things are great to have too, but this video we're only focusing on driveline angle to fix NVH, noise, vibration, harshness problems. So I'm going to click this. By using your smartphone as a measuring device, the app will calculate each universal joint angle and provide an overall driveline operating angle. The results are compared to acceptable angle limits for a typical rear-wheel drive street performance application and will provide a pass-fail response. Okay? If the results provided by this app are within an acceptable range but the driveline vibrations are still experienced, it is recommended that you consult a driveline professional. Alright, so we're going to go ahead and do this. So we're going to hit next. And right, now the vehicle should be placed on a level surface, which is we're on an alignment machine with its weight supported by all four tires. That's crucial. The vehicle needs to be on your suspension because your driveline angle is affected by everything with suspension. If you have bad shackles on your leaf springs, that could cause this drivetrain to change. Okay, if the springs are weak, that could cause the drivetrain to dip or rise. Okay, so you gotta have the weight of the vehicle on your drivetrain so that way it's at the angle that it would go down the road on. And too many people measure the drivetrain angle, or the drive shaft angles, U-joint angles, with no weight and lifted in the air, and that's inaccurate. So, all right. So the weight needs to be supported on all four tires. If available, the use of a drive-on hoist is preferred, like alignment machine. Be sure to take proper safety precautions. So use wheel chucks. Okay. You will be asked to take 3 readings with your smartphone at various points in the vehicle. Use a flat edge of your smartphone and make sure surfaces are clear of debris to ensure accurate readings. All readings must be taken from the side of the vehicle, same side of the vehicle. Orientation from the driver side is suggested. So we're going to take it, so you can take it from the passenger side, so all the readings, the screen needs to be faced this way, or they suggest all the readings to be taken from the driver's side, so the screen needs to face this direction. So now since we understand what's expected of us. Let's do our measurements. All right, so initially we try to measure this is your transmission, try to get the angle off the transmission pan. And the measurement became inaccurate. The ideal place to measure your transmission output shaft angle is on the yoke that is coming out of the transmission. So I'm going to hit next on my screen right now. Okay, so I want to hit next on my screen, and I got an angle. Okay, I'm going to actually horizontally, so that way I could fit it up inside here. And I'm going to sit it right on top of the yoke, right here, on top of that U-joint. Okay, and I'm going to rest on it. I'm not going to force it one way or the other, and then I'm going to hit set. So place smartphone on the surface parallel or perpendicular to the engine crankshaft, transmission output shaft. So ideally, do it at the output shaft. Don't do it on the crankshaft. Hold device steady and press set to record. So set. Okay. Place the smartphone on the flat surface of the drive shaft. So now we're going to take this phone and we're going to go on the drive shaft. Put it same direction, driver's side. I'm going to hit set. Place your smartphone on a flat surface of the rear axle that is parallel or perpendicular to the pinion shaft. So here's your pinion shaft coming out. It's attached to a flange, but the actual drive shaft U-joint is attached to this flange through these trunnions right here, okay, and these caps. So I'm actually going to place it right on top of the... Okay, so I had to reset this procedure because I was pivoting on top of the flange here, which made me get an inaccurate reading. You got to make sure you're on a flat surface. Once when I dropped it off of the flange and down on the U-joint right here, and I made sure I was flush, then I was able to get a true reading. I hit set, and then I'm able to drop it down, and you can see my drive line operating angle is in spec. Anything over a degree, and then I need to figure out why it's out of spec, my drive line angle. Here are some of the things that would cause it to go out of spec. You have a transmission leak on anywhere on your transmission, and that oil comes in and saturates your transmission mount right here. That would change your driveline angle because the transmission mount is damaged or worn out. Same with your engine mount. So engine mounts are crucial. If you have a bad engine mount, that changes your driveline angle. The other thing, if we go to the back of the car, anything with suspension, where it attaches to the frame, your shackles on the front or the rear could affect your driveline angle. Your leaf springs being weak could affect your driveline angle. Your shock absorbers being weak could be a driveline angle. Lift kits definitely affect driveline angle. Notorious from Jeeps. I've seen too many Jeeps where they jack up the thing with an incredible lift kit, but then this driveline angle becomes over exaggerated. And you know, I've seen it where the actual yoke came out of the transmission, or I've seen the U-joint actually snap in half because this drive shaft angle is too steep, and then they went into a high torque or high speed situation and it snapped the U-joint completely in half. So the driveline angle is crucial. I also have a friend of mine who had a transmission that kept on popping out the rear transmission output shaft seal. And if you see the output shaft seal come out of the extension housing, check your driveline angle, because this thing is vibrating and it works out the seal. In really bad situations, the bushing will actually come out of your transmission. In the case of my friend's car, he actually ended up having internal damage because the vibration of the drive shaft continued into your transmission, and then it grenaded all your gears inside the transmission. So it's really crucial to have good driveline angles. Specifically, if this is at 3 degrees positive, then the rear one needs to be at an opposite canceling out angle of -3 degrees. Okay, so we're going to check driveline phasing, which is just as important as driveline angle, and it's regarding a drive shaft that has a slip joint in it. You could get it off of a tooth, or in a high torque situation, drive shafts twist and they become out of phase. What you need is just a tape measure. What's nice about a tape measure is they actually hold pretty straight. I mean, you could put these out. It used to be a game that we used to play. How far out you could hold a tape measure. Okay, drive shafts are no more usually than 8 feet in length, even with the diesels, you know, so it holds it. So let's go underneath the truck and let's check our phasing. Okay, so phasing, I'm not going to have a problem with phasing on this drive shaft per se, because it's a one piece without a slip joint. So, but these can twist, okay? So I could take my tape measure and I go to one U-joint, go back to the other, and you could eyeball it and see if it's and use it as a laser. So now ideally a laser would be the better way to do this, but I'm going to put that in the center there, and I'm going to check it and see if it's centered on this one. And it's just an eyeball to make sure that it's not out of phase, meaning that this U-joint trunnion right here is a line of this U-joint trunnion right here. It's all about eyesight. If you do suspect that this is twisted, you could take it to a drive shaft shop and actually check for sure. I could go to this bottom U-joint, line it up there, line it up here, right in the middle. The tape measure serves only one purpose, and that is to guide your eye, okay? Is it a true straight edge? No, but it is a way to guide your eye to see if your U-joints are in phase. If it was a two-piece drive shaft and someone took it apart and put it together, like I said, they could get one tooth off and now these U-joints are out of phase, and you're going to get a vibration just the same as if the driveline angles were weren't canceling out each other. So drive shaft phasing, drive shaft driveline angles, very important that you check them to eliminate any vibrations. Okay, so now we're on a 07 Tacoma vehicle. It has a two-piece drive shaft with a center support. So I just talked about a driveline phasing, or just the phasing of the drive shaft. So I have a two-piece drive shaft. So in here, this one splines into the front. So the rear drive shaft splines into the front drive shaft. Sometimes you can get these off a tooth. When you get these off a tooth, then this drive line phasing angle, where you draw a line straight through each U-joint, would be off. And we're going to check that after we check the driveline angle. Now the driveline angle is much more complicated when you have a two-piece. So we're going to measure this right here to make sure that this is at 0. If this is at 0 angle, then I could use the front and I could use the rear to figure out my driveline angle. So I'm going to use driveline angle finder again. I'm going to hit next. I'm going to go right up to the U-joint here, or the drive shaft here in the front, and I'm going to hit set. Okay. Then I'm going to go to the middle on the trunnion here of the U-joint. I'm going to go right here to this cap. Okay. And I'm going to get that level with that, hit set, and then I'm going to go to the rear drive shaft and hit set, and you could see that they're pretty much zeroed out. So the driveline operating angle is almost at 0. So now let's go do our regular driveline angle. So again, set this up. Remember, you need to make sure you do all the measurements on one side. Okay, we had to roll the car so that way the yoke coming out of the transmission, the caps to the yoke are 90 degrees or straight up and down. Okay, so now I can go ahead and set my phone on top, and I'm going to hit right here. I'm going to hit set. Okay, now we know that this is pretty much a 0 angle right here, so I'm just going to go straight to my drive shaft and hit set. And now I'll go back to the rear U-joint, and I'm going to put this on the top of the U-joint right here. Get it where it's sitting flat on top. Hit set. And our drive line is perfect. We're under a degree. Okay, so remember, a tape measure, all it is to guide your eye. Your eye is really what's measuring. So I'm going to go ahead and I got the drive shaft up here, okay, the U-joint, and I'm going to put it right on this one right here in the front. And then I'm just going to go straight back and use that as a measuring tool, a straight edge. And from the looks of it, I'm pretty happy with our phasing. Nice straight line. I'm kind of bending it with my fingers, so as soon as I get that all straight. So this drive shaft is properly phased, so driveline angle's good, phasing's good. If he had a vibration problem, I would not suspect it. Keep in mind though, there's one more thing about drive shafts we need to understand. Come on this side, over here. Okay, all drive shafts are balanced. So this is a balancing weight right here. So if you have a drive shaft that's out of balance, the old way of doing things, you put 2 hose clamps onto the drive shaft, and you would put where you tighten the hose clamp together, and then you slowly start to spread them apart. My rule is send it to a drive shaft shop. When it comes to balancing, you can't beat a drive shaft shop. It's a no-brainer. Don't do the hose clamp trick, but I will show you a picture of what I'm talking about.
Now for drive shaft balancing, okay? I mentioned in the video that you could balance a drive shaft using 2 hose clamps around the drive shaft, and you would rotate these until you get the drive shaft vibration eliminated. There are tools available, measuring tools to measure vibrations from drivetrain, and they work. It's a very complicated process. There's another picture down here of someone who used pennies to balance the drive shaft. You know, here's my advice: take it to an actual shop that has the ability to eliminate all the drive shaft imbalances. Okay, drive shaft phasing is another measurement you need to take in consideration. It's about making sure that the U-joint for both the rear and front of the drive shaft are properly in line. They cannot be out of line. If you look at this drive shaft, the drive shaft is twisted, so the drive shaft has a U-joint that is in the opposite direction as it is in the front. Usually when that happens is when you have a 2-piece drive shaft with a slip joint. The drive shafts will become out of phase as someone takes this apart and then gets it on the wrong spline, and then you're out of phase with the front and the rear U-joints. And this would create a massive vibration problem. So make sure you pay attention to phasing as it applies to drive shaft, specifically when you see a 2-piece design or a drive shaft with a slip joint. I found this picture of what I was talking about with the driveline vibration. Vibration was severe enough on this drive shaft that on the extension housing of the transmission, it worked out the actual extension housing seal, created a massive fluid leak out the back of the transmission. If it was the bushing, you don't have to take the transmission apart. You could pull off the extension housing and remove the bushing, or there are special tools that will grab onto it and you can pull out. But whenever you have a driveline angle situation, you need to look at the seals of both the differential and the transmission to make sure they are intact and they are not leaking. In the video, we used a cell phone with an app that we downloaded to measure driveline angle. Or so there's other ways you could do it. You could do it with a magnetic protractor. They make a special tool specific to measuring driveline angle. Okay. What you're looking for, time it's out of specification, creates a vibration problem that could damage your final drive and maybe your pinion shaft seal here, or on the transmission, up by the transmission, you could damage your output shaft to your transmission or a transfer case. The last part of this video is to go over how to find service information. So I like Ford. So I'm going to use a Ford for this example. I'm going to type in Driveshaft. And then just go to Driveshaft here. I like the way ProDemand lays this out. It gives you specifications, causes and fixes, top repairs. But what I'm looking for is OEM testing procedures or general system information. And when I click on this, the first thing that comes up is driveline angles. So universal joint operating angle. It has half a degree all the way to 3 degrees. Okay, so that depends on where the suspension travel is on the vehicle. It does not give us the specification for differences in driveline angle from the front to the rear. This would be that you don't want more than 3 degrees in any one U-joint. Okay, so I say that you need to be under 1 degree difference between the front U-joint and the rear U-joint on a single drive shaft. Okay, so it gives you some other information, but what I wanted to go down to is the procedures for measuring driveline angle. Okay, so here we go. Driveline angle inspection. It's showing you that tool that I gave you a picture of earlier. Okay, and then it's just going to walk you through the process that I just did exactly. Okay, there is a little adapter you can make that goes inside of the U-joint on the drive shaft, so it gives you a more accurate reading, and it walks you through the exact procedure.